Hello students, welcome back. Today we are going to learn about the application of electrolysis. So as we know, we already know the process of electrolysis like by using electric to. So electrolysis, again a process by using electric for a chemical decomposition. For example, we can use electric to split hydrogen and oxygen from water, the compound of water molecule. So what we can do again by electrolysis, for example, we can use it to split the metal. You learned before, metal is actually from an ore, which is called, okay, for example, like aluminium ore, we still call it bauxite. You still remember bauxite? And bauxite means what? Okay, so bauxite is a combination of aluminium, hydrogen, and oxygen. So bauxite got aluminium, hydrogen, and oxygen. So we want to use electrolysis to take aluminium, hydrogen, and oxygen we don't want. Or for example, iron, metal, hematite for iron ore, we call it hematite. If you still remember, and we know that hematite actually is, what is hematite? Okay, it's called ferrum oxide. But that's why it is like a stone, but we don't want the stone, we just want the ferrum, we don't want the oxide. So by using electrolysis, we can extract the metal. But we can see that in this book, it mentioned about potassium, sodium, calcium, magnesium, and aluminium. And it does not mention metal, but if you still remember, metal is less reactive than carbon. So basically, they use carbon to displace the iron from the iron oxide because iron is not that reactive as compared to potassium, sodium, which is on top of the series of reactivity series. If you still remember, so because it's on top, you cannot use carbon to displace it. So what you can do is by using electric. But the problem when you use this electrolysis, it actually use a lot of electric and it will use a lot of money. You use a lot of electric means you use a lot of money to do, and it is very expensive. That is why we can see that aluminium usually is more expensive than iron or tin that is more lower. It depends but I cannot say like that because copper also is very expensive. Copper I think is very hard to get, and yeah, so this is the metal industry. Sometimes it's hard to get, also it make the thing more expensive. Nowadays COVID-19, I found that when I want to buy computer also the computer price increased. If I'm not mistaken, they cannot find silicon to make the computer chip. So now computer price in COVID-19 also increased. So one of it is to purpose of electrolysis. By using electric, we can extract the metal. Purification of the metal. Purify means what? To make it more pure. More pure means more original. So you also might want to use purification. Electroplating of metal means you want to cover the metal. For example, the metal will look more attractive and withstand corrosion. Means there's a metal, but because this metal will rust, so you want to take something to wrap it. Maybe it's a tin. If you know tin that you buy from the shop, the milk tin, you can see it's a shining. But if you scratch the tin, and tomorrow you can see it start to rust. And when it starts to rust, it was inside will spread until it spoil, but if you don't scratch it and it is still fine, so it won't rust because the metal outside layer is protecting the metal inside. So we can use it for electroplating to use some other metal to cover it. And wastewater treatment, okay, we can use it as electrocoagulation to treat wastewater. So we can cause coagulation, means that all the dirty thing will become like a rock, like something, become like something, so that the something you can throw away, rather than all the sand all mixed in the water. It will coagulate the water, means like you will see lah, maybe like a jelly thing float on the water. Then you can take out the thing and the water will be cleaner. Okay, electrolysis. What is this? Electrolysis in electrocoagulation. So we can see from here, first you set it up like this. You need to put the battery first. Put the battery. Okay, so at anode, it will produce aluminum ion, Al3, and at the cathode, it will produce hydrogen. So this is the electrolysis that is happening. One anode producing aluminum ion, and at the cathode is producing hydrogen ion. But coagulation occur because aluminum ion will combine with OH to produce flock. Okay, will produce a flock. Then the flock are trapped in the hydrogen gas bubble and brought it to the surface. The remaining flock zinc accumulate in the base. So we can see that by doing this, all the dirty thing will go down. By using electric, it will produce a flock, and the flock will make all the dirty thing the dirty thing will go down. So again, from this picture we can see this one aluminum 3, and number 2 the hydrogen ion move in, and we can see number 3, which is aluminum and hydroxide ion, are combined to produce a flock. Okay, so that's it. Draw and label the structure of electrolyte cell. Okay, but we need to draw and label. So you just draw lah, no need to make it difficult. Like if you find in Google, the picture will be like more 3D. But you can just make it very simple by, for example, maybe I can draw the battery and draw like this, like this, like this, like this. Depend on you lah, you want to put the switch or not. Maybe I prefer to put a switch lah. Put a switch. No need switch also can lah. Up to you lah. Or maybe voltmeter also up to you. But no need also can. Then maybe he didn't say what electrolyte, so I just assume it's water lah. So, but I don't know want to label water or not because the question didn't mention. But maybe I just label it as electrolyte. So this one I will mention as anode. The reason I know it's anode because here is positive, and this is cathode. Battery and the liquid, the water liquid. And in the liquid, maybe I just write electrolyte. Okay, so this one maybe I just write electrolyte. Okay, do something lah. Make it like water lah. If not, it look like the sand. Unless you do like that, so it looks like water. Draw and label. So I already draw and label. Describe the movement of ion to the electrode during electrolysis. So we want to describe the movement of ion, whether the ion from anode to cathode or cathode to anode. So from that question, we can see that this is at page 180. Describe the movement of ion during electrolysis. So we can see this is the answer. Positive ion will move to the negative electron, which is the anode. Negative charge ion will move to the positive electron, can or not? Because the question asks, describe the movement. So the movement, of course, is the negative ion will go to the positive electron, or negative ion will go to the anode, and then positive ion will move to the cathode. Okay, as according to I showed just now. Give 4 examples of application of electrolysis in industry. So for example of application, you can say that extraction of metal. You want to extract metal, you can use electrolysis, purification of metal, electroplating of metal, and wastewater treatment using electrocoagulation. Of course, there are many more examples for using electrolysis. So up to the question up to you what you want to write, because usually what they ask is the answer they want is from your textbook. So we just give the answer as according to the textbook. Okay, so we already learned electrolysis to produce by using electric to produce a certain chemical compound. Now in 6.2, we are going to learn about a simple cell. Because in electrolysis, we are using electric energy to make chemical energy. Now in chemical cell, we want to use chemical energy to make electric energy. So one of the example is maybe my phone. My phone got a battery. So they are using the chemical energy to make electric energy. Of course, I charge that time is electric energy to chemical energy. Now chemical energy to electric energy. So how to make a battery? I need to know how to make a battery. So of course, you can make a simple battery. First, you can just use a magnesium and copper electrode. You just find a magnesium and copper. I don't know now Shopee everything also got Shopee, Lazada, Taobao. If you just type copper, you just type magnesium, you type copper sulfate solution. I think you can buy from Shopee, Taobao, or Lazada. I think you can buy it. And you can do this experiment in your house during COVID-19. Up to you. So basically, this person there, he want to try to make battery. So what he do is, we need to know the condition to make battery. It won't work if I use the same metal. Let's say I use this I use this and this metal I put inside the water. It won't work because these two things are the same. The metal are the same. It won't work. If you want to make it work, you need to use a metal. First, you need to use metal of 2 different metal. It must be not the same. Put into the electrolyte. Means it must be a different metal. I'm not talking about metal that uncle auntie taught in the restaurant. Metal means every 铁你看到是 metal. I mean not every metal that the uncle auntie taught. When we learn the metal means is referring to the periodic table. For example, like iron, magnesium, potassium, copper, gold, and so on. Okay, we are talking about all the metal that is in the series of reactivity. So he want to use copper and magnesium. Up to you lah. You want to use. So use copper and magnesium, and here you want to use copper sulfate as the electrolyte. Okay. So what will happen if I put like that? Of course, after I put like that, the question will ask, what are your observations? So my observation is I can see the voltmeter deflected. This voltmeter will be deflect. Deflect means what? Deflect means it will move. We can say it's move lah, okay, but a better word is deflect. So this show what? This is the observation. Observation. The voltmeter will be deflected. And what is the conclusion? Is electric is being produced when we immerse two different metals into an electrolyte. Okay, so we know that from this experiment, we suddenly know that we can make electric. Or what we just need to do is just use two different metals. This one in your battery lah. Eventually, if your battery you want to cut open, eventually there are two metals in the battery. You see down here got example of battery or not? Cut battery. Here don't have. Oh, don't have. Never mind, I just show you. So for example, this is the picture that I take from Google. This is the battery that inside we can see there is a different type of metal, and the inside will be anode and the outside will be the cathode. So there will be two different battery, and we can see there is a separator. This one is not coming out in your exam, but it's good for you to know. If you want to make battery, you need to use two different metal. So of course, he got anode and cathode. There's a different material lah, depend on what battery. Now got energizer battery, got what lithium battery, got many type lah, the more expensive and the cheaper one. So it will got different metal. And then we have separator, which is very thin layer to separate the metal from mixing. So they got separator to separate it. So why sometimes battery explode is, if I'm not mistaken, I forget already, last time I got study a bit, the separator start to leak or spoil, then suddenly a lot of electric can go into here, then it will cause the battery to explode. This is what happened during the Samsung phone. Samsung, I think if you still remember, Samsung is the first phone that want to use fast charge phone. He's the first one to develop fast charge, and then a lot of Samsung phone also explode. And one of the reasons is the separator issue, where I forget already, the separator suddenly broken, or all the electric accumulate and go at the same time, then it will cause explosion. But so far the battery you buy, energizer, everything should be quite safe lah. Okay, so we know that in order to make electric, we need to have two different metals. This is the example. Let's look at this one, simple chemical cell. So you can do a simple chemical cell. Already say simple. Simple means you can do by yourself. You can just go Lazada, Shopee and buy, and you do by yourself. I mean, it's nice lah, rather than playing game or what. Maybe you can do this thing, experiment. If you are rich, you can buy a lot of money. I got some student very rich one, so they can just buy. And this is the increasing of electropositivity. You need to use either any one of here and different, then you just put inside the water. Of course, if you want to get the highest charge, you use potassium and silver. This one you get a lot of electric. Compared to magnesium and copper, which is quite, the distance is nearer, so you get lesser electric. The further is it, the more electric that you will get. So by referring to the simple chemical cell, magnesium can become the negative terminal. Well, copper become the positive terminal. So magnesium become the negative terminal. Where's my magnesium? Magnesium become the negative terminal, and copper become the positive terminal. Let's say we want to use magnesium and copper. So copper will become the positive terminal. Okay, so we can see here magnesium donate electron to form ion and dissolve into the copper 2 sulfate solution. So from here we can see that the flow of electron go from magnesium to here. So here go to here, here go to here, here go to here, okay? The flow of electron. So we can see that flow from electron from magnesium to copper. Flow of electron from the up to the bottom. So if you are up means you will be flowing electron to the bottom. So flow of electron from magnesium to copper, and this will make the magnesium is the negative terminal and positive. So how to know positive, negative? By looking at this one. If you are up means you are negative. If you are down means you are the positive. Okay, one thing I want to mention that sometimes, I don't know whether the exam will come out, electron flow don't confuse with current flow. Okay, just remember, when electron flow like this, means the current will flow like this. Current. So I would say that the electron flow from magnesium to copper, but the current will flow from copper to magnesium. So this one you need to take note. What the question will ask, for example, the question will ask, please tell me which one is the negative terminal and positive terminal. So I would say magnesium is the negative terminal, copper is the positive terminal. Then the question will ask you, tell me the flow of electron, or please draw the flow of electron. So the flow of electron I want to draw, I just draw the arrow from magnesium to copper. How I know? Because magnesium here, copper down. So the electron flow from down. If the question say current, then you draw up, because current is the opposite of the electron flow. Maybe the question will ask you to what conversion of energy. So you can say this one is from chemical energy to electric energy. And then maybe the question can ask you, please draw a simple what is this called? Simple chemical cell. So you just draw like that, okay? Just draw like that. A lot of things the question can ask. Or what are the observation? So we can see that from here, magnesium will become dissolved and it will become thinner. Means it becomes smaller. And for solid, copper is formed. Okay, so we can see that the more copper is formed on the right side. Okay, so these are one of the observations that we can see. Yeah, so the first step is you know what is positive, negative first. That is the first step. Second step, you need to draw the electron flow. So at least you know what is happening, okay? At least you know which one is positive terminal, second negative terminal. That is the first step. Second step is to know the flow of electron, okay? So the upper part will be the negative terminal, the bottom part will be the positive terminal. So you need to memorize this one. Up means negative, down means positive. This one you need to remember. If you don't remember this, actually it's the same, I still remember or not? Previous chapter, previous chapter, actually everything is still the same. From 4 we already remember this, right? So if you don't know this, then many questions you cannot do. Okay, so that's it for this video. I hope that you can understand, and I see you next time. Bye bye.